up on October 31st here in Pennsylvania. So if you are located in the Pennsylvania, New Jersey, Delaware region, we please welcome your attendance physically. If you can't, attend, we will be live streaming the event and those details will be sent out. We'll be posting our contact information afterwards, so please do feel free to reach out to anyone on the core side, or if you are familiar with core already and have an account manager or contact, it's very something that's has high visibility throughout the organization, so it's something we can get you the information on. With that being said, thank you for your time again today, and I'll turn it over to Nick.
Good afternoon, everyone. Like Matt said, my name is Nick Gillespie, and to give you a little bit of background, I have been in the enterprise information technology and information security sector for about 8 years now. Started off as a systems administrator for a medical device manufacturer. Then after that, spent some time in the purely security world of a software maker that serves the financial industry. So I've kind of seen web app assessments from both sides. As somebody who's responsible for working with the developers to remediate issues, as well as at my time here at Core, going out, performing the assessments, finding the issues, and then bringing them to the developers. So thank you again for joining today, and let's get started. Just give you a brief overview of what this presentation is going to cover. First, we're going to take a look at the basic value of web application assessment. Why do we specifically focus on web applications? What are some of the properties that bring out the real security value in performing these specific types of assessments? Also, I'll go over a little bit about compare and contrast with lumping an application in with a broader pen test, and why focus specifically on one specific app. Also, we'll take a look at the project structure, show you how Core typically approaches a web application assessment project. There are a couple of different modifications and differences can be made depending on what everybody's individual circumstances are, but we will give you basically what the average case looks like. Then finally, we'll go over some examples. For those of you who may be on the less technical side of things, it'll be a very, very high-level overview of the types of vulnerabilities we look for as part of these web app assessments. Again, not much technical jargon in there, so feel free to hang on the line. Just learn a little bit about that if you're not familiar. And then finally, we'll wrap up with some question and answer. First of all, regarding web applications, everybody knows the importance of web applications of one type or another within the enterprise today. Whether you're dealing with a user-centric, browser-based web application, or whether you're dealing with something that is served on the back end by web services, web applications are integral to the modern enterprise. Part of that is because they provide a very handy framework for passing data back and forth between client and server. Means they can be used for any number of different applications, limited only by creativity and the resources you have to put into developing the application. Many formerly desktop thick client apps have now been replaced almost entirely by thin client applications that run off of an AJAX framework or some other, Web 2.0, Web 3.0 technology. However, that means that, while web applications used to be fairly simple, easy to understand entities, complexity has increased significantly over the last several years, meaning that web application security is getting more and more challenging, especially when you're trying to develop against architectures that are constantly expanding through things like identity federation, and other factors that reach beyond that web application and really tie into an entire ecosystem of different platforms and software. Let's just go over some of the motivations for attacks out there. Most obvious, theft. Many of you are familiar with some of the larger web-based compromises that have happened in the past couple of years. One that springs to mind right now is earlier this year, NBC's websites, a number of their web properties were compromised and were serving malware for a short period of time. That's a very high-profile incident. People come to the NBC website. They are getting these messages from their antivirus programs from the browsers saying, "Hey, this seems to be serving malware. What's the deal?" That's a big PR issue right there. Also, they can be used specifically to embarrass your company, whether it's taking information completely out of context, whether it is posting some type of political message or manifesto, as is the case with the recent Syrian Electronic Army incidents. They weren't necessarily attacking the web application itself, but certainly there have been cases where you compromise a website, you can post your own content on there, and all of a sudden your user base becomes their user base and they get their message out. So that's another possible reason they might want to attack. Also, compromised web servers are used as proxies and relays for all manner of other attacks. So even if an attacker might not want anything that's physically on your machine as far as data, even if they don't think that they can directly monetize anything, they can certainly use your resources to further whatever their goals are, and in the meantime cause you a bunch of headaches dealing with bandwidth issues, performance issues, as well as possibly law enforcement action. So all very good reasons to take note of web application security. The costs, as I mentioned, can certainly be very steep depending on the web application, depending on what's important to your company. Obviously, there's direct fraud liability, especially if you do deal in any kind of transactional information, credit card payments, ACH payments, that sort of thing. In many cases, even if you're not dealing with that type of data, you may have other compliance issues that may arise out of a website compromise. There are a number of state-level data breach laws that require notification whenever personal information is disclosed. So if you have any kind of personal information on that system, that can certainly have a very big impact in terms of any immediate financial loss, as well as long-term customer churn and internal effort to do right by your customers after that point. Following closely onto that, just finding out what went wrong and determining who needs to be notified can be very costly in and of itself, whether that is through additional forensic investigation of systems that may be compromised, whether they were able to use that web server in order to dig deeper into the organization, get to the more valuable assets. That is certainly a possible driver of costs as well. Public perception, as I mentioned before, sometimes people are out there looking for something other than monetary gain. So what an attacker does with your website, like it or not, creates an impression in the customer's mind and puts you in the headlines, possibly for the wrong reasons. Other factors could be downtime costs in general due to the various consequences of the breach, whether that is having to take servers offline while malware is getting cleaned off, or whether it is productivity that the developers could spend working on features instead of remediation. Those are certainly costs to consider as well. Finally, intellectual property value. If that website is what really drives your business, if you have an application that nobody else has, a web server breach can certainly change that. So if people get a hold of your source code, they might have access to your application, might be able to build a competing product elsewhere in the world. Who knows where that could be? So there is definitely value in being proactive. Vulnerabilities that are discovered early are often a lot cheaper to fix, which is why we always recommend that some kind of web application assessment would be part of your organization's SDLC. It's not to say that you need to have somebody looking at these applications all day, every day running scans, although it would be nice. Most organizations just don't have that kind of time. They don't have those kinds of resources. So you'll see different approaches to that, whether it's performing yearly scans of critical web applications, semi-annual, or whether they perform scans prior to release of major features or other major changes within the information processing environment. It is very good to kind of get into the routine of these sorts of assessments. It helps your developers keep security in the top of their mind so that if you make the same mistake once, you're less likely to make that same mistake again. Not only that, but as new threat vectors are discovered and made public, it's not going to be a new thing to remediate these vulnerabilities. You're going to have that process in place. You're going to know the drill. So it's good practice in general to continue to have these sorts of assessments, especially on your most critical apps. Finally, it does reduce your operational risk by remediating any holes that might be out there that we can find before the bad guys do. It's not to say that the bad guys can't get creative. It's not to say that there aren't other vectors that can be used to attack the application or its underlying infrastructure, but certainly it does make it a lot more difficult for the attackers to do so. It also could make it a lot easier for you to identify something that something is amiss and quicker to recover from. So the methodology that core BTS uses in its typical web application assessment is based off of a crystal box approach. We like to start off with interviews with key information technology staff and also key business staff, if that's possible within your organization, so that we really get a handle on the role that web application plays within your organization, so that we begin the assessment with as solid a functional understanding as we can. We also conduct system configuration reviews so that we understand technically how the application is positioned on your network, what other applications feed into it, where its output goes, and how the surrounding operating systems and other critical components are secured, trying to call out as many of the potential failure points as we can. Finally, we conduct dynamic testing on the web application as it sits in your environment. For the employee interviews, we really want to understand a number of things about the application, including its purpose, how many people use it, is it a customer-facing application, is it a purely internal application, do you have any external partners that log into the application. We want to know what the roles that people typically have within the application, how they log into the application, their skill level, anything that we can find out that might help us really understand where the human factor might fit into the security of the application as well as the technical factor. We also look to understand the overall architecture, any programming constructs that are used, programming conventions that are used, if there are any frameworks or middleware that are essential to the delivery of the application, because they can also be attacked just like the rest of the app and factor into the product's overall security. The data is very important so that we know what types of information that application will be processing, and if there is any risk of that data aggregation. Maybe you might not have social security numbers, but you do have fields that could be aggregated with other fields elsewhere in the application that could be potentially hazardous. Also, we want to make sure that we really understand. We want to make sure that we really understand the data that everybody puts into the system and how it feeds your business as a whole. In addition, we all know that systems are often put in place with one intent, and then the users find inventive ways to do their job, which, people are trying to do their job, but it may not mesh with security best practices. So if there are any gaps between how a web application is intended to be used and how users actually are using the application, that can be significant from a security perspective. For example, if you have a document sharing solution out there that's intended only for, let's say, website content, all of a sudden, a user decides, hey, this would be really, really easy for me to, work with my vendor, and I can just put some, some user lists up there. My vendor can log into the application, pull it down, and, that way they've got, the mass mailing that needs to go out. Say it's a printing company. That's all well and good, but if that site was only intended for content, and we find out that somebody in the business is using it to hold personal data for people that might be on corporate mailing lists, that certainly changes what some of the security requirements could be. And certainly, if that's not called out in the business requirements for the application, that could also have some interesting business continuity effects as well if that application were to ever go down. So we do often find these gaps, and they're often the more interesting parts of our assessments, to be honest with you. Also, we look for weaknesses in overall design and maintenance practices. So if we see that your code itself is pretty tight, we don't see any sort of injection attacks or cross-site scripting attacks, which I'll get into a little bit later, but if we find out that you're not patching the underlying web server, well, that could pose a problem as well. Everybody knows that patches are essential these days, especially when you're talking about externally facing applications, in order to really keep your servers functioning in such a dangerous environment as the modern internet. So we also want to identify those practices, as well as possibly backups, making sure that you have a plan to restore that application in the event of a disaster, especially if that application contains data that is critical to the functioning of your business. Hospitals need to have emergency access procedures for certain web applications that might contain EPHI. So there's certainly some compliant tie-ins in there as well. As part of our system configuration reviews, we like to take a look at the various pieces of the web application. We look at the web server, obviously, because that's going to be what's at the front door. If you have any load balancers or anything like that, we do take that into consideration as well. The application server itself, pretty much any kind of three-tiered architecture. We like to take a look at all the different moving components. Middleware also, if there's a web application that depends on say, a third-party content management tool, or even a third-party ActiveX add-in or something like that, we like to take a look at that as well. Just make sure that all those components are working well together. We take a look at things like local security policy on the machine. We take a look at whether group policy is properly being applied and that's functioning in your environment as you expect it to. We also take a look at other supporting devices for the application, including firewall, switches, routers, because if you're depending on your web code to protect your back-end database, you have to be sure there aren't any, quicker, easier ways around that. So that is certainly an important part of what we do as part of web application assessment. So for those of you who might not be as familiar with web application testing or any kind of software testing, there are two basic types. There's dynamic testing, and then there's static testing. In dynamic testing, we are testing running code and seeing how the application handles our input. What we do is we like to use either a test environment or the production environment. We will run our tools against that code as it stands, basically tampering with the parameters of the web application on the way up, and then seeing if that affects what we get back on the way down. That accounts for things like system configurations. In the many steps it may take to get from the web server to the back-end database, there could be any number of unknown variables there, and then we'll know what the final result is from our individual tests. We can perform dynamic testing from a variety of different user roles, which is to say that I can log in as a plain old user, perform the same set of tests that I would use from an unauthenticated user perspective, and then kind of compare and contrast, make sure that there are no greater security risks for authenticated users as opposed to unauthenticated users. Finally, dynamic testing can be applied to multiple different web frameworks. We don't have to have a custom web framework for a custom testing framework rather for Java apps, PHP apps, ASP.NET apps. We're taking a look at some of the idiosyncrasies with each of those packages, definitely, but we can apply the same testing methodology to all of those when we're looking for input validation errors, when we're looking for other configuration errors. The drawback is we do have less visibility of how widely an identified vulnerability may affect the underlying system. We also don't know exactly where that vulnerability fits into the architecture sometimes. We've got a good idea, but the developers would probably be the resource to go to identify those sorts of things with dynamic testing. Static analysis, on the other hand, is the process of taking a look at the source code, stepping through it, and looking for vulnerabilities in coding practice. Sometimes you can do that on a small scale, very manually. When you're taking a look at larger applications, though, it generally requires some very, very complex software to help out with that. Also, when you're performing static analysis, it doesn't necessarily take into consideration how the application is going to behave for one user as opposed to another. It may be very difficult to direct the software to take a look at those effects. Also, it may not consider the other outlying factors that may affect the overall application security, such as the configuration of a web application firewall or load balancers or any other middleware that might be in there. Oftentimes, these static analysis techniques are very platform specific. So you need to have a tool that's capable of assessing all of the different languages that you use. And it has to make sense of the input that gets passed back and forth in between all of the key components of the application, whether it's the web server, the application server, the database server. However, static analysis does have the potential to identify very, very complex programmatic weaknesses. And I'm not saying that static analysis is completely worthless. For some customers, it definitely is. For some customers, it definitely is rather a very useful exercise. But we find that dynamic testing is much more efficient, and that your return on investment is going to be probably greater than it would be for static analysis for most small to medium-sized applications with limited budget resources. So, going over some of the main points I touched on before, it also requires less upfront developer time. Yes, we do ask to interview the developers to get a general idea of how the application works under the covers, but we don't need to sit down with your developers and understand exactly what your coding standards are. We don't need to step-by-step go through the lines of code and go through all the comments, determine what objects do what, and go into that level of detail. We're able to start testing without taking up your developers' time so that they can work on other productive activities as well. As I said before, it evaluates the code in situ, in place where it is, so that the entire environment is part of the application assessment, not just the code. There are a variety of open source, proprietary, and custom-built tools out there that do help us perform this assessment. We sometimes develop our own tools that we will then deploy on the application, depending on if there's an interesting use case for it, if there's a novel way the application works that nobody else has done anything similar for. So we certainly do have that capability. And finally, it kind of leaves developing to the developers. We will give you a general guide for how we see organizations addressing the types of vulnerabilities we find. We might not tell you need to go into this file and add this function in order to sanitize the input. Oftentimes, the developers that spend their entire day in the code are going to have much more elegant solutions to the problem, much more efficient solutions to the problem than we will. So we find it's best to let the developers continue to develop as long as we give them, clear instructions on or clear guidelines on what the security risks are and what sorts of things would eliminate the security risk. Some typical tests we do as part of a dynamic assessment include forced browsing. That's situations where you might have a parameter in the URL that is looking for, say, a unique identifying number. Say you're looking at an article on a blog, and you want to find out if, well, I'm reading article number 92 now. What happens if I put in article number 130? Well, is article number 130 published, or is it still being drafted? If it's still being drafted, we want to make sure that we can't get to that before the content is done. Otherwise, some other media organization might scoop our story. So that's one sort of thing we might try with forced browsing. Parameter fuzzing is a little bit different, where we will try to give types of information that parameter wasn't expecting, see how the application reacts. Feature abuse is very, very broad. As I mentioned before, web applications are very versatile apps, and they can be used in all manner of ways they weren't intended. One of the things that we try to do, especially when you have an application that allows file attachment, we want to make sure that that can't be used as a method to propagate malware. Because if there's a method to propagate malware out there, the malware writers and botnet operators are probably doing it. So we want to make sure that we can't attach any malicious files that may harm your users, your company, and allow the attackers to gain any kind of internal access. We can try privilege escalation. There are a number of different vectors for that depending on how the application is architected. Basically saying, all right, well, I'm a user, I should have access to this and this page. If I tamper some cookie parameters, can I give myself access to other pages? There are also a couple of different ways you can try to escalate your privileges outside of that. There are some vulnerabilities for specific platforms that we'll try and leverage if we can find appropriate exploit code for it. We'll also take a look at any publicly available files and see if we can access sensitive data in those files' metadata. Oftentimes, applications that host a lot of content will hold a surprising amount of information that you don't know is even out there in the first place. PDF files, Word documents, Excel spreadsheets are often great repositories for things like author names, user lists. I've even found, rarely, but I've actually found passwords in metadata before. Not often, but it does happen. Also, we will test to make sure that your application and any middleware has strong credentials. We'll make sure that we can't just try admin and then get right into your application. If we can get into your application as an administrator, we can pretty much do everything that you can do, and so can the bad guys. Default credentials are very, very easy to get a hold of on the internet, usually just a Google search away. So those sorts of minimal effort attacks are definitely worth an attacker's time to try. So we'll get into some of the more common vulnerabilities that we run into. Again, if you have any more technical questions, please use the question and answer feature. I'd be more than happy to provide more information at the end if you would so desire. So cross-site scripting, just to give a brief overview, is where we are able to interact with the content going into a web application in such a way that somebody else using the application interprets it as a command. So what you're seeing in the graphic off to the left is a JavaScript message box with the letter 1. That's a fairly simple, fairly standard way to demonstrate a cross-site scripting attack. The most common flavor of cross-site scripting attack uses JavaScript functionality within most browsers these days. And again, browsers have, varying levels of protection against cross-site scripting. However, unless you have complete control over the types of browsers that your client uses, which in most industries these days, most sectors who are looking at things like bring your own device and are seeing increasing mobile activity, it's getting more and more difficult to control exactly what browser your client is using. So you really have to have those controls built into the application itself. There are many different ways to use cross-site scripting attacks. There are so many different methods to initiate your own JavaScript coding. For example, you can use a JavaScript statement within an HTML parameter sometimes. Sometimes it's as simple as adding in a script tag and then putting your JavaScript in the middle. Sometimes you need to escape out of an existing JavaScript statement, and just by adding in a quote, you can write your own JavaScript that way. So again, very, very difficult to really to mitigate all of those little point possibilities there. So if we do identify cross-site scripting attacks, we will work with you and we'll suggest different ways to remediate it that will address as many of those possible scenarios as possible. So SQL injection and other injection type vulnerabilities are perhaps some of the most dangerous vulnerabilities that we work with. In many cases, in many web applications, the web application is connecting to the back-end database with a certain set of credentials. And it's actually the web server or the application server that is designed to provide the access control to that back-end data. Sometimes we run into situations where there are controls on the SQL tables themselves. That's definitely best practice, not what we see most of the time. And if you're in the same boat, if your developers are in the same boat, SQL injection attacks would be very, very important, because that SQL injection attack enables us to execute code directly on that database itself. So we can select data that was never intended to be selected, and what you see on the right-hand side there is a redacted SQL injection attack. Basically, we are querying a table for information that we were never supposed to be able to query or sort by. In that way, a SQL injection attack can result in very, very quick data disclosure. Unlike a scenario where you compromise the operating system and then have to go through various layers of security to get to the valuable data, that tunnel is already there between the web server and the database server. You're abusing that tunnel as it sits. So that's a very important class of vulnerability that we concentrate heavily on. As I mentioned before, weak credentials, also very important because it is a very, very low-skill attack. It can be an attack that is perpetrated by the most skilled of attackers, the least skilled of attackers. It can be perpetrated by a disgruntled former employee. Also, it can be perpetrated by political activists. There are a number of different ways people can guess your credentials. Some people out there are very, very good at it. To give you an indication, with the LinkedIn breach a number of years ago, actually it might have been just last year, I forget exactly the date of it, but credentials were stolen from LinkedIn, and they appeared on an online forum somewhere. Now, the best the researchers could do is they could crack something like 200,000 of these, however many million passwords. And the bad guys who were posting on these forums were already able to crack, 3, 4, or 5 times that amount using the techniques that they've developed. The bad guys are very good at this. They are, in some respects, even better than the good guys sometimes. So certainly a very, very valid vector of attack. So thank you again for joining us today. That's pretty much all I had pre-planned, so we'll go to the question and answer if there are any.
And we did actually have some questions come in, and please do take a moment if you want to use the meeting center to send a question in. We'll be sure to get to it. We had someone ask about, what kind of tools we use for testing. I'll turn that over to Nick, but I'll say that there's no one tool. I'm sure the security tool vendors would like you to think that there is kind of one tool and to buy it. I mean, we use a mix of both commercial and open source tools. The open source tools that you can get your hands on are actually plenty good. And Nick, I mean, we both do testing, but you kind of talk to some of the things that we use and do.
Sure, absolutely. Like Matt said, there's a lot of different tools out there. And as I mentioned before, it's one of the reasons why dynamic testing is so effective, just the availability of tools that are out there. I can tell you that, I have probably anywhere upwards of 30 tools that I go to, depending on the situation. One of the main ones I use is and I'll speak in broad classes here because it can get to be like Mac versus PC, Ford versus Chevrolet type debate of this tool is better than the other tool. But in broad classes, I would say that I use non-transparent proxies. That's my #1 tool. That's where I can actually place myself as a proxy in between my browser and the server.
Some examples of that are like
Paros
is old as can be, but still around.
Paros proxy, burp proxy, OAuth Zap.
Yep.
And I believe there are a couple of commercial alternatives out there as well that do similar sorts of
Most
attacks.
of your big commercial tools are going to have like a suite of tool sets. Burp Suite is actually named Burp Suite because it is a suite of tools, as Nick mentioned. And most of the commercial products are going to be like that, and they're going to have a module, a component that's the proxy. I mean, to be honest, a tool is a browser even. I mean, we use a browser just to kind of check things out, check headers, check comments, or check code for comments and things like that. I mean, we use other tools to kind of put that together, but even just a browser, it's some Firefox plugins. I mean, maybe speak to some of your favorites there. I got my own too.
Yeah, Firefox plugins that are out there. There's also, I believe, StanCat browser based on Chromium. That's another one that's commonly used. Let's see, other tools, Metasploit for some of the exploits that are going after underlying server-level vulnerabilities. Really, there's a very, very large variety, and I'm also a big fan of Python. So if there's a problem that there's not a tool out there readily for, I fire up Eclipse and make myself a Python script to do what needs to be done.
Yeah, and there's other tools like Nick2 is, again, quite dated, but it's still something that you can even throw at a web application. It's still available. Again, there's people want links, you can email us and we can kind of point you to some links for tools. Some of the tools are even hard to come by, but there's even tools like more vulnerability scanning tools are taking on, like even Nmap has some things that it's doing now on the web app side.
Absolutely.
Skipfish is doing some things on the web app side. So there's a number of things that you can use. One thing I'd want to call out is there's good tools out there like Web Inspect and oh my gosh, I'm missing a couple of the commercial ones that just escaped my head. But the commercial tools, yeah, that's true. Acunetics has a tool, and what we don't want you to do is just go run that tool and kind of look at that output and say that you did an application assessment. I think that's kind of the theme here, is that you can go do that, and a lot of organizations, a lot of consulting firms, unfortunately, do that. And that's why we try to position what we do as a differentiator and a value add, because you can run that tool and it'll give you some good feedback, but you still need someone to go through it and interpret it for you. If you just run that tool and look how it flags high, medium, low, and that kind of stuff, you're missing quite a bit from the risk equation.
And also, just as importantly, those tools require skilled operators behind them, because especially if you're running the tool against a production environment, they can absolutely be dangerous. If you have a web parameter that says, delete this node or delete this line in the database, and then that tool just blindly goes down, hitting that parameter for all of the different unique identifiers, you can find your database missing a whole bunch of data. You can have some pretty severe integrity issues with that. So definitely a good idea to make sure that you become very, very familiar with both the tool and the web application, and be very, very careful.
So another question was around, does dynamic testing identify the specific lines of code at issue? And I mean, it can. Sometimes certain error messages that we get that are helpful during like SQL injection testing will say, you'll get a database error message dump that says, code line, blah, 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 blah. So, Nick, I don't know if you want to speak to that a little bit more.
Sure, yeah. Sometimes we'll get an ASP.NET yellow screen of death that'll give that sort of information. Hopefully not if it's a production instance. We like to see descriptive error messages turned off. Typically, I would say we don't get into that level of detail unless our client asks us to, and even still, there is a limitation as far as our ability to dive into the code. If it is a vulnerability where we believe that we can, kind of help you trace it to the code, that might be something that would be discussed as part of the project design process with Matt or Tim, who's also on the call here.
Yeah, I mean, what I'd say to that is we certainly have, and as your advocate, if you have your own internal development team, or if it can help, if you've hired a third party and they just are like, hey, we're developers, we don't kind of get this security stuff, we have and will get on the phone and try to help them understand. Certainly the flip side of that is we're not developers either. While some folks on the team might have experience, we also don't dedicate 8 hours a day, 40 hours a week to development. So there's quite a bit of knowledge that we might have, but the developer's kind of going to bring what they understand to it.
And critically speaking, the developer is going to know the code better
Right.
than we are in most instances. So, if we tell them, all right, we see a problem on this page, they're most likely going to know the objects and their parent objects and child objects better than we will.
Yeah.
So oftentimes, if the developer is available, it's a more efficient use of everybody's time to have us speak with the developer and describe what we did to produce the error, and then the developer can take a look and actually remediate that error.
Sure. Another question came in around web application firewalls, and really the gist of it was, how effective can they be and how disruptive can they be to us? And the answer is that they can be. There's no, we have clients that have asked us to do testing as their environment is deployed in a production capacity, so the application firewall is up in front. And, most of the modern application firewalls, Citrix has a NetScaler out there that fills that role. That is something that, because of its architecture and design and what it does, it will filter out some of the traffic. Now, we're, as testers, always going to say, do not rely on that one control. A lot of times they're working, any kind of application firewall is going to be functioning with some kind of signature, right? It's going to be looking for some string of characters that it deems potentially malicious. And then, what we and other attackers will do is play the encoding game, right? So if the parentheses is the bad character, if the single quote is the bad character, we can encode that, HTML encode it. There's a million different ways to encode and double encode and do different encodings embedded. So you can play that game, but again, the application firewall sometimes are almost playing whack-a-mole. So what I'd say is they're a great control that we run into fairly regularly, but as with any control, I wouldn't rely on it, Nick, solely rely on it.
And, taking off my penetration tester hat for a second, putting on my security analyst hat, I would say that web application firewalls can be very, very useful as a tactical control, meaning that, all right, we've identified this vulnerability, and we know that this needs to be fixed in the code, but it could be a very, very complex process to do it. So what I can do is I can leverage that web application firewall to remediate that vulnerability on a temporary basis until I have the ability to quality control the rest of my code, make sure that it's not going to break anything, make sure that it's not going to introduce any additional risk. And I think that's a very, very big win for web application firewalls, that they can provide that level of flexibility and that level of quick protection, even for zero-day exploits.
The next question was around some specific static code analyzers and things that look at the code and some specific products. And yeah, I mean, the truth is there are plenty of products out there. You can kind of pick your major IT vendor, whether it's HP or whoever. They have plenty of tools that do that. Things will look at the code, but I think, again, our theme here is we're not code reviewers. That's not what we do by trade because we're not developers. But when you look at dynamic testing as what we bring to the table, it is a different approach. And sure, you can kind of go run a tool and it'll give you some feedback as to what's wrong with the code. But again, keep in mind how those work. It's going to be looking for certain kinds of things and certain constructs that you're not, there's always going to be a hole when you have kind of a blacklist in a sense that you're defining and then going and looking for things.
Absolutely, absolutely. And also those packages do tend to be fairly expensive. The open source packages that are out there to identify security vulnerabilities through static analysis, there might be a couple out there for a couple of the different platforms. You know, some I'm sure are better than others, but they're not nearly as available as dynamic testing tools are.
And it's also a matter of where it gets engaged, right? So sure, if you have a big development staff or you're a large organization, or you have a number of applications and you have development teams that you're paying that are third parties, sure, bake that into the SDLC. Bake that into your development process. Fine, but very often we get engaged when things are a bit later on in the process. Not that those static tools are kind of confined to earlier on in the process, but I think that's where you're going to see your real value. And then we would love to be engaged at any point of the development process, but typically it's going to be an application that is alpha or getting ready to be so. It's going to be pretty well along. So,
I mean, we would recommend, unless you're an organization that spends probably upwards of millions of dollars a year developing web software, we would typically recommend that you bake more code review into the SDLC where, yes, you are taking a look at the source code at the developer level for potential patterns that it could indicate security vulnerabilities, but we would recommend that's included early, maybe as part of a unit test or something along those lines, so that it makes the process a little bit more manageable, and you don't have to outlay, tens of thousands, potentially hundreds of thousands of dollars for some of these higher quality static testing tools.
Yep, great point. And that's all the questions I think we have for today. I, again, thank everyone for attending. We kind of ran right up to our time. We're actually a couple minutes before. We realized we cut into some folks' lunches, so we appreciate your time this afternoon. Again, our contact information is up there. Feel free to reach out to anyone on the core side. If you are a current core customer, thank you very much. You should hopefully know how to get a hold of us or folks at core. Again, a reminder about our security conference, October 31st, and that we'll be continuing our web series the first Wednesday of every month, so you'll get another notification about that. Thank you, everyone, and have a great day.